What up? Here's the core layer configuration video. Last video we configured up the distribution layer, and if you read the description in that video, I left something out again. Seems to be a trend going on with me. Maybe in every video I'll try to intentionally leave something out to see if you guys notice, but I don't think that will be a problem because I leave stuff out anyway. But basically what happened was when we copy and pasted the config from distribution 1 over to distribution 2, I failed to change the spanning tree priorities. So what we ended up with was the same spanning tree priorities on distribution 1 and 2. So basically to fix that, we just need to change the priorities on distro 2 for VLANs 10 through 13 to 8192, so that it'll be the it'll be a lower priority than distribution 1. And we need to change the priority for VLANs 14 through 18 to 4096, so this will be the root bridge for those. Now I'm not going to go through that configuration. I've already changed it on here. It's pretty straightforward, self-explanatory. You can do it pretty quick, so I'm not going to go into that. I'm going to go into what we're going to do in this video though. We're going to configure these two switches up here along with our server switch. Now I actually have a plan for this area now. Basically I threw that in just for you to visualize our kind of local network data center here. But I have a few changes to make to this actually. It's not going to be exactly how it's shown. So first in this video we're going to set up our routed ports here, 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 as well as our Etherchannels, which are going to be layer 3 routed ports as well, connecting the core to the distribution. And after that we're going to configure routing, obviously, on our core switches here, and a little bit on the server switch. Now, this isn't going to be actually how a core layer is supposed to be. In the real sense of a core layer, you really want it to just route traffic as fast as physically possible. You don't really want any software processing going on in your core layer because it'll just slow things down. So the real way you'd have a core layer is you'd have a shitload more connections off of it to a shitload more distribution layers, which have an ass ton of access switches. So you really just want these to route traffic to your distribution layer as fast as possible. But the way we're going to set this up is kind of as an external access layer, sort of. So it's going to be our access to the internet. So what we're going to do is we're going to run some access lists and actually NAT on these for our internal network. So the end result will be all of these hosts in our internal network, as well as these actually, are going to be NATed to our global addresses right here. So that basically this is just so that these hosts can access anything on the internet, but nobody on the internet will be able to actually access anything on our internal network. Now we're going to leave this open. We're going to create what I'm going to call an internet VLAN off of our server switch, so that our web server that we're going to have here is not going to be NATed. We're going to have a subnet that will be accessible from the internet, and we'll have free flow in and out of that. But these two over here, we're going to have our like DHCP and our NTP, syslog, just some internal servers. They're going to be on a separate subnet, which will not be able to be accessed from the internet. And how we're going to do that is, actually this is where the change comes in. We're going to throw these two subnets out the window. We're not going to have routed ports here. Instead, we're going to swing this link to core 1, and we're going to make these links layer 2. And just have an interface VLAN here for our internet subnet. We're also going to have an internet VLAN, or not an internet VLAN, a VLAN for our internal servers. And that's just going to be in the routing table of our internal network. So the only two subnets, actually 3 subnets that'll be accessible from the internet will be these 2 external links and whichever VLAN our web server is going to sit on. Now, how we're going to segregate everything from the internet is going to be by running 2 routing protocols on these 2 switches right here. We're going to run Ospf, which is going to connect to the internet. These are running Ospf already. And they're only going to include and advertise the directly connected link to the core switches and this subnet. Now, they're also going to be running egrep for all of our internal networks so that it can communicate with all of these, but that's just going to be routed internally, and egrip will have a default route pointing out to the internet. So hopefully that made sense. I really have no written down script kind of or overview of what I'm going to do. I just kind of came into this, and hopefully I can make it through this video without fucking some shit up. So let's just go dive right into the configuration. First, I'm just going to set up the routed ports. I'm not going to worry about the routing. Oh shit, the routing or anything right now. So on core 1, configure terminal, we're going to go to interface gig 01. Now this is our link down to the distribution layer. So we're just going to do the no switch port command, turn this into a routed port, give it an IP address, which as we can see from the diagram is 5.0.1.13 with a /30 mask. Ooh, my mask is a little too short there. Alright, move on to gig 02. No switch port, give that the IP address, which is going towards the other core switch, 5.0.1.9 with /30 mask. And our internet port, fast Ethernet 024. No switch port, give that the IP address of 5.0.1.2, also a /30. Okay, so our main routed ports are now configured with an IP. Now let's move on to the Etherchannel ports, which we use the interface range command, fast Ethernet 01 through 2, which are the links to distribution 2. Now to set this up, we're gonna go ahead and put the no switch port command on them, turn them into layer 3 ports, and we're gonna use the command channel group, and we need an identifier. So this is just going to be a local ID for this port channel interface that we're going to create. Oh, bless me. So we're just going to use channel group 1 here, and we need to assign it a mode. Now this is where we're going to choose our Etherchannel protocol. So we're going to be using either LACP or PAGP, and whichever one of these commands we put in here is going to be the determining factor for that. So LACP is going to use the keywords active and passive, and PAGP, which is Cisco's protocol, is going to use auto and desirable. Kind of makes sense because if you notice on switches you have like DTP, like mode auto, desirable, whatnot. Kind of matches up. Their Etherchannel protocol uses pretty much the same keywords. So for this one, as you can see for our diagram, we're going to use LACP to connect to distribution 2. So we're going to use mode active. And active is kind of the aggressive mode of this. So basically the difference between active and passive. Active is going to actively seek out to create a connection, and passive is just going to sit there and be like, yeah, you know, whatever. And if it gets a message from an active port wanting to establish an ether channel, it'll be like, oh, okay, well, sure, let's fucking do that. If we have passive on both sides, they're not going to do anything, because they're both going to be sitting on their asses waiting for someone else to do something. So after those commands, if we do a do show IP interface brief, we'll see that we have a new interface here called port channel 1, which we can go into using interface port channel 1 and assign it an IP. I'm going to assign it the IP address of 5.0.1.21 with the /30 mask. Now the verification command for this will be do show Etherchannel summary, and we can see here we've got port channel 1 RD. What that means is it's a layer 3 ether channel, and D means that it's down, wherever it says that at, yeah, D, down, and both of these ports are independent. So these are working just like nothing has changed. They're independent of each other, blah blah blah. This isn't going to come up till we configure the other end on distribution 2, which I might as well do right now. See if it has the same port assignments. It does. So we're going to go in, configure terminal, interface range, fast Ethernet 01 through 2, no switch port, and And we're just going to use channel group 1 over here again, except we're going to use mode passive. And we're going to go into interface port channel 1 and give that the IP address of 5.0.1. What do we got here? 20. We use 21 for core 1, so 22. Now if we do show Etherchannel summary here, we'll see that we've got a change here. Port channel 1 is routed, layer 3, and U means it's in the up state. And shows here ports fast Ethernet 01 and 02 both have designator P, which means that they are wherever it is. It means it's bundled in port channel. Yeah, there we go, in port channel. So our port channel between core 1 and distro 2 is now up. Basically that allows us 200 meg bandwidth total between those two switches. Now I'd read up a little bit on how port channel works, because it's not actually 200 meg, it's just 200 meg total. Maximum speed you'll get out of it is 100, unless you configure load balancing, which we're not going to do. But that's another story. We're just going to hop on to core 2 here and do the same thing we did on core 1. So interface gig 01 link to distribution 2, no switch port, give that the IP address of 5.0.1.17 /30 mask. Interface gig 02 link to core 1, no switch port, IP address 5.0.1.10 because we used .9 on core 1 already, /30 mask. Interface fast Ethernet 04, our internet port, no switch port, IP address 5.0.1.6, not 5, /30 mask. And let's pop over to our ether channel. Interface range fast Ethernet 01 through 2, no switch port, and the group. We're going to use 2 for this just to be creative. And I keep hitting enter after that as if it's going to do anything. We have to assign it a mode, which we're going to use mode desirable here because we're going to use PAGP. This is Cisco's keyword for aggressive mode, auto being non-aggressive. Okay, so now we can go into interface port channel 2 and assign that the IP address of 5.0.1.25 with the /30 mask. Now on core 2 here, whoops, we've got one more link that we need to configure, which is interface fast Ethernet 03. This is our link to the server switch. And we're going to do the, actually this is going to be a switch port. No, just kidding, it's not going to be a switch port here. So we're going to use the no switch port command and give that the IP address of 5.0.0.131. Now I'm going to explain this right now. So the change I'm making here is we're going to get rid of these routed ports, so we can just X off these subnets here. And I'm swinging this over to core 1 on fast Ethernet 03 also. Now these two are going to be a part of this subnet. So I'll just put this here for the whatever, easy visual reference. So going along with that on core 1, if we go into interface fast Ethernet 03, no switch port, we're going to assign that the IP of 5.0.0.130. 240. So now what we've got is these two switches acting as routers on the exact same subnet as this switch and our web server. So over here we're going to configure these as trunk links, and I'll show you how to do that. I'm not sure if it's going to be in this video or the next. I haven't really decided. Depends on how long I go with routing and NAT on these two core switches. Might save that for the next one. But let's finish up this port channel that we started. That was kind of a side tangent. So interface range, fast Ethernet 01 through 2, no switch port, and channel group 2, Now this doesn't have to be the same channel group number, but I'm just keeping it uniform. And we're going to use mode auto. Not compatible, will be suspended. Vlan mask is different. Okay, what do we got? Not really sure what that means, actually. These were those same ports, yeah. Alright, let's just go with it. Maybe it'll come up. Interface port channel 2, IP address 5.0.1.26. 25 was taken by core 2. Do show Etherchannel summary. Yep. Well, Fast Ethernet 1 came up into the port channel. Fast Ethernet 2 did not, which is the one that said we had a problem with. So let's do shell run again. Look at Fast Ethernet 02. We need to see what configuration is different. I don't see a different configuration, actually. Maybe it was on core 2. Mode desirable. Not really sure what the issue is here. Let's just go into interface range. Fast Ethernet 01 through 2 again. And do a shut, no shut. Alright, that brought it up. I don't know what happened there. But now our port channel between these two switches is up, distro 1 and core 2. Alright, so all of our links pretty much that we're going to be using are up and they have IP addresses. So now I'm going to move on to the routing. So starting on core 1, make this window a little smaller. Go into router egrip 69, the autonomous system number we've been using for this whole thing. Need to enable IP routing, so let's just do that real fast. One command. And let's start throwing networks in. So 5.0.1.12, which is our link to distribution 1, using the .3 wildcard mask. That link came up. Or neighbor adjacency came up, not the link. 5.0.1.8 is going to be our link to core 2, using the same wildcard mask. Our link to distribution 2, which is 5.0.1.20. Yeah, we've got a flapping adjacency. That's always awesome. And for this, we're going to use the command redistribute static. Now I know I don't have a static route right now. God shit, why does this thing keep going up and down? Alright, let's make a static route. This is going to be our static route out to the internet. So, all zeros, first two, just like every other static route. And we're going to use 5.0.1.1 as our destination. Bam. So now this route is being redistributed through the EIGRP process, which is kind of our gateway out to the internet. Now the second thing we want to do is set up Ospf here. So we're going to use process identifier 10, and we're going to put in the networks 5.0.1.0 with the .3 wildcard mask. We're going to put that in area 0. Now this is to connect with router 7 up in the internet. We're also going to throw in network 5.0.0.128. with the .15 as the wildcard mask, but we're going to throw this one in area 1. So this is going to be our internet subnet, which will be advertised out onto the actual internet. And I really wish I knew why that thing was flapping, but I don't, so we're just going to move on to core 2 and do the same thing. Whoop. So starting with router EIGRP JRP69. Oh, gotta enable IP routing. Always forget that too. IP routing and no switch port, two commands that I always forget. So let's just start throwing in our networks here. 5.0.1.16, link down to distro 2. That adjacency came up. 5.0.1.24, which is our link to distro 1.3. That is up. Network 5.0.1.8, link to core 1.3. That is also up. And network 5.0.1.4, which is our link out to the internet. Now also we're going to throw in 5.0.0.128 server Vlan and write that. Now we're also going to create Ospf 10 over here as well with network 5.0.1.4 in area 0 and 5.0.0.128 in area 1. Bless me again. I'm just going to go back into JRP69 and do the no auto summary command. Alright, looks like we've got an Ospf adjacency with the server switch somehow. Yeah. No. 21. Where's 21? Not really sure what that is. We'll figure that out later. Okay, this shit's still flapping. Do a show run. Look at JRP. We only put in 3 networks over here. Looks like we didn't put in everything we needed to. We need our internet link 5.0.1.0, and we also need our internet subnet 128.15. Do a show run. It's not obvious yet that I have no plan for this. Alright, 1, 2, 3, 4, 5, so that should be good. 1, 2, 3, 4, 5, yes. Okay, so routing is now set up. And why the hell this thing keeps flapping, I have no idea, but it's pissing me off. Okay. So now comes NAT. So to set up NAT, we need to first do an access list, because that's what we're going to use to mark interesting traffic. By interesting traffic, I mean addresses that are going to be translated. So I'm just going to do access list. We're going to call it 10. We're going to use the permit statement, and the network that we want to permit. Give me 1 second. I'm going into the console and doing logging synchronous. Okay, so access list 10, permit 5.0.0.0, and we're going to use the wildcard mask of 0.0.127. So we're only going to go up to our internet subnet because we don't want to NAT that. And we're also going to permit 5.0.1.8 with subnet mask of what should we do here? What do we go up to? Let's just use 127 here. So that's going to take care of most of, well, definitely all of our internal network access links. So those will be translated as well if we decide to ping from them. We'll write that. And now we need to go into interface fast Ethernet 024, which is our internet port. And we're going to put in the command ipnat outside to identify this as the outside interface. Now we're also going to go to interface gig01 and use the command ipnat inside to identify this as an inside port. Now we're going to go to 02, Do the same thing. Port channel 1. And fast Ethernet 03. Actually, well, yeah. We'll do that over there as well. Okay. So now we have NAT set up. And we're going to do the same thing over here. Could use Notepad to copy and paste this, but I'm not going to. Access list 10 permit 5.0.0.0 with the 127 wildcard mask. And we're going to change this to 1.4 with also 127. Or not 4, we used shit. We used 8, didn't we? 1.8. Interface fast Ethernet 024, IP NAT outside. And interface gig 01, IP NAT inside. Interface gig 02, also IP NAT inside. Interface port channel 2, IP NAT inside. And interface fast Ethernet 03, IP NAT inside. Oh, there we go. So, to actually enable NAT, we need to put in the command IP NAT inside source list and give it the access list 10 that we created. And we're going to map that to interface fast Ethernet 024. So it'll take our outside global address, which is configured on that interface, and it'll NAT everything to that. We're going to use the keyword overload so that we use port address translation. This is what we want to do instead of configuring a pool. And that's how we enable NAT. Let's do the same thing over here. IP NAT inside source list 10. Interface fast Ethernet 024 overload. So once we get these routers talking, then we'll be able to do some ping tests between our web server up here on the internet and our hosts down in the bottom. So to bring these links up, both of these are on fast Ethernet 1.0 on these routers. So we just need to go into those. Fast Ethernet 1.0, assign it an IP address 5.0.1.1 with a /30 mask and do a no shut. Now we're going to do a show run and see what networks we're advertising here, which is everything on this router, so that's good. Should form an adjacency with Core 1 as we're running Ospf down there as well. Just going to hop over here to router 8, configure that up. Configure terminal interface fast Ethernet 1.0, IP address 5.0.1.5 with a /30 mask and do a no shut on that. Make sure we're advertising everything over here as well, and we are. Why don't we have an adjacency forming here? Make sure our port here is configured right, 012. I'm losing my port because this damn thing's flapping so much. Okay. Oh, there we go. Alright. So Ospf is loaded on router 7 and do show IP Ospf something here. Neighbor. Well, there we go. Loaded. Okay, so we've got Ospf running here and here, along with egrep. Let's just do some ping tests. I'm going to go from PC6. I statically assigned this guy an IP. Just kidding. Apparently that was in another save file. So we're going to statically assign it 5.0.0. I don't know, 20. What? We'll use 21 instead. Fuck it. 240 mask 5.0.0.17 is the default gateway for this host, and don't need a DNS server. So let's do ping 2.2.2.1, which is our web server up there. And we're getting replies. So to verify NAT, Core 1 we're going to do is show IP NAT translations, and we see down here inside global address 5.0.1.2, which is our internet port address, inside local .21, the host we just pinged to outside local, this was our destinations. So you can see that it used ports 1, 2, 3, 4 for the 4 pings that we sent. So it translated those successfully. Now if we go to our web server that we just pinged, and we try to initiate a ping back to 5.0.0.21, we should see that this fails. Now the reason this fails, well, one, it's because of, actually it's not because of NAT, this is because we don't have a route up here. So if we do show IP route on router 7, which is closest to the network, you'll see that we only have a route for 5.0.1.4 and 5.0.1.0 and 5.0.0.1.28, which is the 3 links that we wanted to advertise to the internet, both of our external links to core 1 and 2 and our server subnet. Now, some other things we're going to want to do here is just some random stupid shit like hostname core 1, set up the VTY lines with that access list. I'm actually, you know what, I'm not going to do that. We've already done that on the distribution layer and the access layer. So just assume that the same thing can be done here. We'll put the management access list on the VTY lines. Now what we do need to do is create an interface VLAN 18 or yeah, and assign that the IP address of 5.0.0.18 or 123 like we have on the diagram here with the 240 mask here, and add VLAN 18 to the database. See that VLAN 18 is up. Protocol is down. Yeah, whatever. Go to core 2, do the same thing. Interface VLAN 18. Give that the IP address 5.0.0.114. And add VLAN 18 to the database. So let me just make sure I'm not leaving anything out here. I am going to save the server switch configuration for the next video, so I'm not going to worry about that right now. I think that's pretty much it. So basically what we did in this video, this long kind of scatterbrain shitbag that you could call a tutorial, we configured our routed ports, brought up routing using egret process 69 between all of these devices here, and then we split that process off to Ospf 10 to connect to the internet. We also set up NAT on both of these to translate all of our internal hosts addresses to our global addresses here to access sites on the internet. And by doing that and also segregating the routing table, we prevented anybody else on the internet from directly pinging our host's IPs. So pretty much the only IPs that we have visible to the internet are on these 2 interfaces and whatever we choose to put off this server switch on our internet VLAN. We also configured the Etherchannels, PAGP and LACP. Hopefully you remember the keywords that go with each of those. PAGP is auto and desirable, LACP is active and passive. And those are both layer 3, not layer 2. So yeah, pretty much that is the core layer, which is not an actual core layer example, but it's an external access. So thanks for watching. Hopefully this wasn't too scatterbrained for you, and hope to see you in the next video where we set up the server switch and our web server.